Karl Fischer titration. Karl Fischer titration is a method of titrating developed by scientist Karl Fischer in the 1930s. Since then, the method has been used by scientists everywhere to carry out experimental procedures. Karl Fischer titration method is used for water determination in various compounds. Water can directly or indirectly enter food or drugs, and a known water concentration is needed to correctly establish the lifetime and stableness, as well as important in every step of the way from initial product till the finished product. Generally, titration is defined as the process in which one solution is added to another solution, such that it reacts under conditions in which the added volume may be accurately measured. More specifically, the water concentration in Karl Fischer titration is accomplished by using an iodine-iodide redox reaction. Karl Fischer titration uses sulfur dioxide for the organic base compound and iodine. It usually includes the addition of methanol or ethanol as well. Titration is performed until the water is consumed and the endpoint is reached. There are two main types of Karl Fischer titration: volumetric and colorimetric. Volumetric titration includes the direct addition of iodine to the titration cell in a reagent. This determines the water concentration based on the volumetric measurement of reagent. This is a good procedure for establishing high moisture levels. Volumetric is the most common and can be used with solids or liquids. The titrant is dispensed and calibrated with standards, and the endpoint is determined with a platinum electrode. The water concentration is read directly off the barrette by reading the mark, then subtracting the final by the initial value. Colorimetric titration is accomplished by passing a current through an iodine-containing electrolytic cell. The water concentration is found by the time and current in coulombs used to generate the iodine and is a good option for low moisture levels. Colorimetric titration is a current between the cathode and anode electrodes and generates iodine. Only liquid can be used in this form of titration. The limit of detection is lower than volumetric at 1 parts per million. The solvent and reagent are in the same liquid, and the electrical current passes the reagent. There is no peristaltic pump used in colorimetric titration. When using Karl Fischer, certain things should come into play. The ideal pH is between 5 and 7. Certain reagents should be avoided because they react on the side and cause water consumption and changes the endpoints. The sample size should be large enough to get usable data, but not so large that titration time runs long. Other precautions include avoiding unintentional water, such as water in the instrument and the sample. Also, the sample should be titrated but not over-titrated, and should be fully dissolved in order to contain usable data. Conductivity is important in coulometry. The detection limits are vast for Karl Fischer and can range from 1 parts per million to 100%. The use of volatile compounds is one advantage of the Karl Fischer titration because the method is not affected by them. Coulometry titration allows for low moisture levels to be measured, and the volumetric allows for high moisture. Both give more accurate and precise data. The main advantage of Karl Fischer is that it provides a specific detection of water and is an easy way to detect the presence of moisture. A disadvantage includes the volumetric method having a 50 parts per million limit for titration to work. Also, the water should be easily found in order for it to come in contact with the titration reagent. The paper Determination of Water Content in Meat Pâté by Karl Fischer Titration and its Moisture Sorption Characteristics uses a Karl Fischer titration method to determine the water concentration in chicken meat. A methanol chloroform solvent mixture, a 1-to-1 ratio, was the most optimal titration for this determination. Water concentration in food is a popular analysis for the food industry because its water concentration can affect characteristics of the food. Though other methods are applied for this analysis, Karl Fischer titration is the most consistent in accuracy and precision. In this experiment, Karl Fischer titration was coupled with the oven dry method. Sorption isotherms are product-specific and correlate the water content and activity. This experiment uses a meat pâté which is ready to eat and very nutritious. They are stored at a set temperature, yet despite this, several food poisoning cases have arose. The meat pâté is a solid form of ready-to-eat meat, while the solvents are liquid. The two types of meat pâté were chicken and poultry. The titration reagents used were analytical grade, having a water content below 0.1%. They were commercial compounds purchased from European countries, including Germany and the Netherlands. The goal of the experiment was to obtain data using the Karl Fischer titration to determine the water content in a meat pâté and compare it to the moisture measurements found from the oven dry and sorption methods. The quantitative data is the water content in percent of the samples. The qualitative data would be the sample type VSP versus VSE. VSP represents the chicken meat pâté and VSE represents the poultry meat pâté. The figure depicts the influence of the sample size on water content and the extraction solvents. When the sample size becomes greater than 0.3 grams, the water content will decrease, and vice versa. Karl Fischer titration is a method used to determine the water concentration in a particular food or drug. This method is the most precise and accurate for this type of experiment.